This lesson is called scientific notation, and essentially it's pretty straightforward. All we're doing is learn to convert numbers between standard form and scientific notation. Now, scientific notation is used a lot in science, particularly subjects like physics, even chemistry, they use it a lot, hence scientific notation. Standard form is just a normal number, all right? So just all the numbers that you've encountered so far, since you remember about what numbers, that's what it's talking about. So hopefully it's pretty straightforward, okay? And let's get on with the lesson. Okay, so the Earth and Mars are about, that should say are about that far in kilometres apart. It actually depends on where you measure it from, but yeah, they're about that far apart. It says, can we change the scientific notation? So the answer is yes, you can. So what we try to do is that we put that first number, so this one, and we go 5, and then we put a decimal point straight after it. It's normally the case that we do that. It's unusual for you to see, you can do this, but it's unusual for you to do this. So first number, and then we're going to put the decimal point, okay? Then we're going to put the other numbers after that. So the 4 and the 6, we're going to put after that. Now, I haven't specified how much in scientific notation I want you to put it in, but it doesn't really matter. Okay, so what we've done is that we've put a dot after the 5. So what we're going to do now is count from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See how there's 10 spots? That's really important, because then we're going to go to change to scientific notation. We're going to go times 10 to the power of 10. Now this 10 relates to the 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whilst this 10 is different, that's just part of the scientific notation. Scientists love things in terms of 10. Mathematicians were a little bit different, but for this case we need to learn that. All right, write the following to 3 significant figures. So we've got the same question doubled up, but we've just got the 3 most significant figures. Quickly, if I've got $142,999, which are the 3 most significant figures? Now they're the first one. That first one is worth $100,000, okay? So that's the most significant. The next one is the second most significant because it's worth $40,000. Not quite $100,000, but it's quite a lot. The next most significant is $2,000. All right, so the first 3 numbers are usually the most significant. Now they've got to be non-zero, okay? Even though this is a higher number, it is not worth that much. That's $900. It's not worth as much. So the first 3 numbers are always the most significant. So I'm going to leave that highlighted. So we're going to write the following to 3 significant figures, but also express in scientific notation. All right, so I'm going to put my decimal point here, all right, just to guide me. So I'm going to go 1 point. 3 significant figures will mean that I need to cut it off here. Now, to round, I look at the number after the cutoff and I think, is it 5 or higher? And if the answer is no, in this case it's no, then this number there, which also happens to be 4, stays the same. So that's really good for us. So 1, 3, 4 times, now I'm going to put 10, because that's the start of scientific notation, and then I'm going to count from the decimal point. 1, 2, 3, 4, 5, 6, 7. So it's going to be 10 to the power of 7. And we're going to show that we know how to round this by going 3 significant figures. You know how we do that with decimal points? Well, we're going to do that here as well. All right, now with these really, really small numbers, and sometimes that happens, you know, with size of atoms or size of microscopic hairs and stuff like that. We use these really small numbers. The first three most significant figures are the first three non-zero. So that's this one, and this one. So I'm going to need to put a point there, okay? All right. So I'm going to write this down. So it equals 6.773. Oh, no. That's the three most significant, these ones. So I don't need to put 4 numbers. Okay, just like here, I only need to put 3 numbers in. Okay, now I'm going to times it by 10 to put in scientific notation, but what is my power? Well, my power is, go from the dot, 1, 2, 3, 4, 5. So I'm going to have a 5 at the top here. But notice, it's not going to, this is a really, 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 really small number. Okay, because of the decimal point and everything. So it's really, really small. This one is really, really large. Okay. So the way we differentiate that in maths is that we put a minus in front of this one. Okay, so it's a really, really small one. Okay. So that's the way we write it. And essentially that means that it's a decimal, the negative part of it. When we do index laws, I can explain it a bit further. But essentially, if we want a really small number, we've got to put a negative there, okay? So we still count, and then we move on. All right, the same 2 questions, but now we're going to 2 significant figures. So the 2 most significant figures are the first 2 non-zero. So that's this one and this one. So let's do it. 1 point, oh, that's my line there, isn't it? Is this number 5 or higher? No. So we stay the same. And then we go times 10, and it should be the same as the other one. 1, 2, 3, 4, 5, 6, 7 to the power of 10. 7. It's positive because it's a really, really big number. The next one, to 2 significant figures, that's going to be there. Now, is this number 5 or higher? The answer is yes. So that means I have to change to 1 number up, which is 8. Change to 8. So let's do this. 6 point, it won't be 7, it'll be 8 because we're rounding. And remember, when it's 2 significant figures, we only need 2 numbers. And then we're going to go times 10, and we're going to count again. Make sure we've got it right. 1, 2, 3, 4, 5. And remember, because it's a really small number, it's going to be minus 5. All right, that's my lesson on scientific notation. So peace.